Hello and welcome back to our final part of this logistic regression modeling guided project. We're focusing on the credit card approvals, and this is a data set from Kaggle. So we've just seen our modeling. We looked at different examples and ways we can expect our errors and look to improve our model. So we started with group by, and then we went into yellow brick visualizers to get some more detail and more texture on where we're making the errors. So we kind of made some decisions in terms of there are some features that are very different in our errors, and it might be valuable if we emphasize those differences in our model and then give our models essentially something to push off. So what we're going to do is we're going to define a little function. So we're going to define when the age is over 50. And so what we'll do is we're going to create a little function. So define age over, and we're going to give it one feature. This is going to be the row value. So an X colon, and then we'll go if X is equal to or greater than 50, what we'll do is we'll set value equal to 1. And then because we're really going to not have any other situation, we'll just do else, and we'll go X equal to, or sorry, value equal to 0. And so we're going to then return this value. We'll run this and we get the value. So the way that we would now use this little function to engineer another feature is we'll go df, and so we're putting this on the column we're going to engineer. So we're going to go across age, we'll go dot apply, and then we'll go age over. And just notice that I'm not putting in parentheses here. I'm just going to give it the function as is. And so here we'll run this, and then we can see here, if we ran this, what we'll do is what we get from this function, if we go dot value counts, we get zeros and ones. So we have 59 people that were over the age of 50. And this will help give our model something to push off of for those older clients in case there is something of value in this. So what we'll do is we'll do a gender cross column. So what we have is we have df, because we went ahead and coded this already. So we have gender and then 0. Oops, 0. And then what we want to do is we want to multiply this by, it's not plus, multiply, and we'll go df income. And so we're going to do the same thing again. So we're just going to basically, when it's one gender, we'll multiply by the other. When it's another gender, we'll multiply it by the other income. And this will give us our model something to push up, because we did notice that that income do provide a different value. And having a feature cross allows our model to push off of when those differences occur in both cases. So it can lead to overfitting, but we're giving our model something extra to push off of. So we're going to do another feature cross here. We'll go df. I have to finish writing before I hit enter. So df, and then we'll go gender 0 again here. And we're going to multiply this by when the over 40 the feature that we just engineered is also valid as well. So we'll go df, and we'll go age over 50. And so what we'll do here is we're just going to run that. We're going to copy this one down here before we run that. And so we want to put gender 1 for this next one. So there we go. And we get another feature that we've been created. So one of the last things that I want to do, if we notice the errors that happened a lot for income being 0. So let's just create a feature to signify when income is equal to 0, but we're actually going to do a little bit less than 0. We're going to say when the income is less than, let me change this right here, when income is less than 200. Okay, so what we'll do is we'll do the same thing that we did above. So define income less than 200, and we're going to pass it x, which will be the value in the row. And so we'll go if x is less than 200, oops, sorry, 200, and if that's true, we'll go, if that's true, we'll go value equals 1, and then else value equals 0. And then we'll return the value. So we'll do this. And so let's run this across. So we'll go df across our income column. So income dot apply, and we're going to go this income less 200, the function we've just created. So if we run this now, we'll now have a feature, a one-hot coded feature that will basically be 1 when the income is less than 200 and 0 otherwise. This will give our model something to push off of. So we'll do the train test split again now, and you can see here I'm giving it the same features, but I'm giving it the engineered features as well. So extra features, but the same idea. I'm going to do the feature, list of the features. Then I'm going to then use the list that I've created and the list for the target to select out from the data frame, assign that to X, and got to make sure you're running your cells all the time. So the same thing we did up above, assigning those to df features equals X, df target equal to Y. And so we'll assign the same thing. We'll do X train, X test, Y train, Y test. And then in the train test split, we'll give it X, Y, and a test size of 30. We'll then fit our logistic regression using the X and train, their new kind of logistic regression. We're going to assign this to score train 1 or score train 2, score test 2, so that we have access to this and we can make a comparison in the next screen right here. So we're going to go score train, and we're assigning that here. Our first set of score, the second score, scores test, first score, second score, the normal, our second version are the model names. We're going to assign that to a dictionary of the list of values, and then we're going to put pd.dataframe. We're going to give it the dictionary, and we're going to give it the model names in the next one, so model. Okay, so if we run this, we can see here that we get, our score actually went down a little bit. So we can see that we got a better training score and a worse test score. I tried, and I was not able to get this to get a better score, but this goes over a whole bunch of different feature analysis or error analysis techniques that you can use to improve your model. It does not always work. There are no simple short answers here, but this is something that you can try and improve your model. And we can see we didn't get worse. We added some more features, so we didn't overfit, but we didn't help it. And there might be a limit to how good we can do. So what we're going to do is we're going to look at the test of the first model. And so let's give it the name test 1. And so we plot the confusion matrix of the first one, and we can see that we get 43 errors over here in the bottom left. And so let's see how many errors we get in our second one. Our accuracy score didn't improve, but what we can see is that where we made the errors did improve significantly. We reduced this was our biggest one that we wanted to focus on for this classification problem, is when we predicted no and the actual was yes, because we would want to lend credit cards if it's available, because we make a large profit on those versus the extra marketing and costs of predicting yes when someone wouldn't actually get approved. It's an extra cost, but it's very small compared to predicting someone wouldn't get approved when they actually would have. And so if someone would have gotten approved for a credit card, we want to make sure that we're contacting those people, because we end up making, I don't know, like 20 times, maybe even 100 times more money than what we would spend in the other situation. So we can see here that we did improve it from 43 to 14. So we didn't improve our accuracy, but we did improve the business value of our model. So thank you very much for joining me on this guided project.